Hey everyone,
Hey everyone.
we'll give a few more minutes as people hop in. Hello, Louise. I noticed you're mentioning hello in chat.
Yes, hello to everyone.
Hello. And we have a hello from Anna-Roza. Hello, Dimitri.
Hello.
Hello. Hey, Tenmise. Hey, Likey. Hello, Amita. Okay. All right. So as everyone is coming in, um, I just want to say hi to everyone, Um, and it might be really awesome if we have a bit of an icebreaker, you know. Uh, if you want, feel free, if you are so moved, to type in, oh, and we have a hello from Anna-Roza. Hello, everyone, and welcome to the Case Study Showcase. If anyone wants to type in their favorite AI tool that they are currently geeking out about into the chat, that would be awesome. That would be a chance for us to kind of, geek out with each other, about favorite tools that we are interested in. We have from Ritu Perplexity, Snowflake Cortex from Dimitri. Awesome. Thank you. Thank you, Ritu. Thank you, Dimitri. Others that you want to post. Luis, deeplearning.ai. Thank you. Semantic Ranker from Chad Koziel, who is one of our stars for tonight. Oh, and Peter says, not allowed to use any at my company at the moment, but allegedly, otter.ai is good. Awesome. And thank you, Peter. And Tiba says, Tiba's iPhone specifically says ChatGPT 4.0 with its new launches. Gemini and AI feature in Jira, LOL, Shruti says. Awesome. Cool. Okay, let's see how things are looking. And it looks like we have a good solid number of people in who have joined us in the participants in the participants list. Um, let's see. As we are all hopping in here, I wanted to say um, hey, I'm Ray Hsu, and along with those of us who are in the, oh, we have more people coming in. Along with those of us who are part of the AIPM community peer group as part of the TPMA, Toronto Products Managers Association. We have here Anna-Roza, we have Pratik, we have Simi, we have Pallavi, and also Sophia is part of us as well. Let's see. Oh, closed captioned transcript is being generated. I just wanted to give a thank you to those of us who are part of the organizing crew. I also want to say thank you to Andrew at the TPMA and also the TPMA, of course, for making this possible. But yeah, I just wanted to give that thank you right off the bat.
Happy to help out, Ray.
Of course. We'll give another few seconds for people to pop in. Awesome. I want to make sure that we also, of course, shine a spotlight on our speakers for today. We have Richa, and we also have Chad. First off, I want to mention, Richa Deshwal is going to talk to us today about how the launch of a natural language processing powered tool transformed revenue models in the news publishing world, driving a tenfold growth in subscriptions across multiple target customers internationally. And also, I will go on to introduce Chad as well. But yeah, I just wanted to give a heads up, about the exciting talk that Richa is going to be giving us first. Okay, Richa, shall I hand the mic over to you? Do you want the floor?
Yes, I'm ready.
Perfect. Thank you, Richa.
Can I present my screen now?
Please do.
Okay. Thanks everyone for joining. How is the publishing industry using AI? I will share an AI product from the Globe and Mail case study today. I'll start with my introduction. My name is Richa Deshwal. I'm a technical product and project manager. I manage data science products and some data analytics projects as well, working at the data department of the Globe and Mail currently. Whenever I introduce myself to TPA members in any of the events, people get surprised what a data science manager is doing at an old newspaper. AI is used in every industry. In fact, the publishing industry has been using AI since a decade. This is all I'm going to cover today in the presentation: history of the publishing industry and why they adapted to tech and AI. I will give example of an NLP product which was very successful in generating revenue, challenges of commercializing an AI product and its impact on data and algorithms. I'll briefly touch upon the risk of using AI. I think it's a very important topic, and we'll wrap up with key takeaways. The history of publishing industry. I'll showcase the timeline and milestones from the Globe and Mail, but there are similar timelines for all the publishers across the world. So you can get an idea that around 95 is when digital newspapers were introduced. And initially, the main revenue stream for them was advertisement, but around the early 2000s, because of rise in social media and social media advertisement, newspaper could no longer just rely on advertisement revenue because it went on decline. And they had to pivot and innovate and focus on subscription revenue. So there were quite a lot of solutions implemented. In 2015, an NLP-based paywall product was introduced, which helped in generating subscriptions. And in 2018, Globe and Mail had this department, Sophie, which is a separate company now. They started commercializing this product and selling it to other newsrooms as well. In 2024, this is where we stand today. I'm working on some generative AI-focused use cases. For this presentation, I'll share the example of this paywall product and what were the challenges faced in commercializing it. Before we dive deep into the paywall product, I want to share what paywall means. Paywall is this annoying layout that blocks us from reading news and articles. And so this is example of paywall from the New York Times, which is asking you to subscribe before you can view the article. There are other kind of walls as well. For example, red wall, which will force you to register before you can view the content. And there is another kind of wall, which is very popular in publishing industry today. You can see the screenshot from Harvard Business Review. It is showing me that I have only one free article left this month. It's called Meter Wall. And it meters certain free articles that you can view for free before it asks you to register and before it asks you to pay. So when these publishers are focusing on subscription revenue as their mainstream of revenue, ideally they should be paywalling everything and forcing users to pay and subscribe for their content, but they're not doing it. See that they are providing some free articles metered, or there is a huge amount of content which is never paywalled. So why are they doing that? Let me answer that in the next slide. When you have a high paywall rate, which means most of your content is behind paywall, it can ensure high subscription revenue for a short amount of time, but it will impact your engagement rate. Users will not know what kind of content you're writing. They will not be able to read your articles. They won't know whether you're writing facts or biased articles, whether your content is interesting enough or not. So this will bring your brand value low, and eventually it will hit your subscription revenue, and it will start, users will start subscribing less. High paywall rate also inversely impacts your advertisement revenue. Advertisers pay publishers when a user views their advertisement, and if everything is behind paywall, if the advertisement is not shown, they do not get paid. So if high paywall rate is not a solution, is low paywall rate a solution? It is not. It can ensure high engagement rate, high advertisement revenue, but it will not give you subscriptions, so you won't end up making money. So what is a solution? An optimal paywall rate, which is a balance and not too high, not too low, is a solution. Earlier in the newsrooms, editors were making this decision which articles to paywall, but they faced decision fatigue and information overload. Earlier, they were either doing a guesswork, which articles they think may do well, or they were using data analysis, which was a lot of information for them to maintain optimized paywall rate. So we don't want editors to face this issue. We want them to continue doing what they do best, which is writing fantastic stories. That's why we started using AI for paywalls, which is to make the decisions which article should be behind paywall. So Global Mail worked on this product called Paywall, which was using AI and NLP. And how I define it is it is a real-time decisioning system. And I want to stress on real-time decisioning here because it's very, very crucial for the publishing industry. The moment any article is published, it should be decided whether to paywall that or not, because news is only newsworthy when it's new. No one's going to pay for an article which is 3 days old because it's already available for free on multiple platforms. And this system analyzed not just the content, like which content can bring high subscriptions, it also focused on users' propensity. For example, if I'm a person who reads a lot of finance news, there is no point in placing paywall in front of my, if I'm reading an entertainment-based article. I will not pay and subscribe and to view that. I will have propensity to subscribe if I see a finance article and it has good information for me. So this system not only focuses on content, but users' propensity to subscribe as well, to decide when to show a paywall to visitors. And this is how it is able to achieve that optimal paywall rate, which we talked in the previous slide, by targeting the right content for the right users and letting the remaining content be for free. And it maximizes conversions, ad revenue, and engagement. So this product increases subscription revenue without unduly sacrificing the advertisement revenue. Now, some A/B tests were conducted when this product was launched. They were A/B testing done with 2 buckets of users with 50% in each bucket. Keeping the paywall rate same, we saw that the bucket of users where the AI was making decisions for paywall had 50% higher lift than the control where the editors were making decisions. So this was definitely a success, and eventually we moved it to 100% decision making. And Global Mail was able to see 220% decrease in registrations and very high subscription numbers as well. Now, this kind of A/B test is not done just for human versus model, AI model analysis. It is also sometimes done for AI model versus AI model analysis, especially when you are deploying a new model. You tend to introduce it only for a certain, like a 1% audience, and then measure it against your old existing model, whether the new model is making better decisions and desired outcomes or not. Now, when this product was a success at the Global Mail, it received a lot of attention at conferences and awards globally. And there was a high demand for this product in market. And why not? Because if it's helping bringing subscription revenue, which is the main revenue stream for publishers, all of them would be interested. So high in demand, especially in countries like US, some countries in Europe and Australia and all over the world. So it was time to expand and commercialize this product and sell it to other newsrooms as well. But there were some challenges in commercializing this product. There were some changes required at the code level. Code had to be more modular and scalable. We had to introduce configurability to remove hard coding. This product was created for the business needs of Globe and Mail. So there were a lot of business use cases hard coded, and it required to be configured so to adapt to the business needs of the clients. Then it required integration with different data sources. Each of these publishers or the new clients, they will have their own tech stack and systems to store and publish articles, and they will have their own analytical system to test user traffic. And this product required both article information as well as users traffic information, analytics information in order to work. So integration with different data sources was required. And then there were some cost cutting done to introduce multi-tenancy in cloud infrastructure. If you maintain different infrastructure for each client, you won't be saving any money. So this was a cost cutting initiative. You can see there were some challenges and changes done at code level, configurations level, data pipeline level, and infrastructure level. But there were additional challenges to this product because it's based on AI and it heavily depends on data. So data will be different for each of these clients, and they will have different user base and different needs. To adapt to that, there were some additional challenges. I'll name some of them here. Some of these publishers were non-English publishers. Some publishers from Europe wrote in non-English languages. So the product was not making right decisions, but then we decided to translate the articles before feeding it to the model, and then it started working better. There are some publishers which has both national and local news consumers, and their propensity is quite different. So an experiment was introduced to label binary values 0 and 1 to these kind of users to understand their trends and their propensity, and then decisions were made better. Now, some of these clients, they were happy after the A/B test was done and they let the AI control all the decisions. But some of these publishers asked for overrides request, and they said that they understand their business better, so they will want some kind of control to override their decisions made by AI. So this was challenging, especially to maintain optimal paywall rate where decision is made by AI as well as humans. So this was quite challenging. So a lot of changes were required. This one is kind of obvious. Some publishers, they have business needs of high paywall rate as high as 50%, but some have business needs to keep the paywall rate as low as 20%. So some sort of configuration was required. So after these changes, the product is Sophie, which was a department at the Globe and Mail, is now a separate company, and this product is still being sold and solving and helping a lot of publishers. I'll list out some risks at a high level. One is the number one is the model performance. It is much easier to test a software engineering product, but for testing an AI product and what accuracy it's building, it's much complex. I talked about the A/B tests in one of the previous slides, where you can test the previous and new model and evaluate the performance. But it's not a very straightforward test. Even for A/B test, you have to wait for longer, sometimes weeks and months to understand the paywall performance. For example, for a client, it's possible that they have high user traffic in the morning, and there are more people reading news and versus in the evening. And they may have higher traffic over weekends versus weekdays and vice versa. So you have to make sure that your model is working for all kind of user traffic. So it sometimes requires patients to test it for weeks for 1% population. And then as you get confidence, keep increasing that. But it's definitely much more complex than a software development product. Then regulatory compliance is very important. You should work with your legal team to understand. The North American countries have different regulatory compliance than the Europe. So you have to be adhering to that and have good understanding of that. Then data privacy is also very important, that you're not feeding any PII data to the models. It can be quite sensitive. I can share one example of a use case that I was working recently, which received user feedback from a form, and the form had only 2 fields. One was like you could rate your satisfaction from 1 to 5, and it had one comment section where you can add any comments if you want to add any additional information about your satisfaction level and what you have given. I was not expecting PII in that information, but it ended up having PII, which was caught by the privacy team, and people were adding their phone number and email address in the comment section, which was not expected. So you have to very critically look at each use case, whether there is PII or not, and take this very seriously. You can also lose your job because every company is taking AI very seriously these days. Last but absolutely not the least risk is the budget constraints. These AI models are costly and they can work across your budget very quickly. There are some measures you can do it, like for every POC, you can have some cost tags in your cloud infrastructure environment and products like Databricks. You're able to monitor how much it's costing. But if it is costing much more than it's going to benefit you, you should have confidence to kill the project immediately, because these products can be very costly. And especially look at whether you really need to use AI for this use case or not, because don't use AI just because it's cool. Use AI only if it actually fits in your budgets and it is going to give you a benefit or not. I'll wrap up with some quick key takeaways. The publishing industry have been benefiting from AI solutions. Data science products, when they are commercialized, they require more adaptation than software engineering products. To mitigate risks, the product managers have responsibility to implement robust user persona analysis to make sure algorithm is adapting to each kind of user base and clients. And there is a high risk associated with using AI. So you should really assess if AI is the right solution for your business needs or not. Thank you.
Awesome. Thank you, Richa. So we have 5 to 7 minutes for questions, and it would be great to be able to dive into it a bit. Talking about this in the realm of publishing with Richa, we are going to be moving on to finance with Chad afterwards. But yeah, let's dive into Q&A. We have 5 to 7 minutes. Oh, Peter mentions in the chat, we have a similar issue with customers sharing PII and even restricted information files via chatbot and email during support interactions. That's fascinating. Yeah, thank you, Peter. Chad says, how do you design user-based A/B test structures for the product where the paywalls are typically at the article level? Any thoughts, Richa?
These A/B tests, yeah, they are done at user level. So you're bucketing your users and noticing their behaviors. So for example, if 50% users in the control group, which has like an old model, are they subscribing more versus the other bucket of users, are they subscribing more or not? So it is done at user level and seen that which model is making better decision within the A/B test.
So thank you, Richa. We also have questions. We have a thank you from Sonali. Great presentation, very insightful. Dimitri says, unrelated question, is Gen AI used at Globe and Mail at all? If yes, what are ethical considerations? Any thoughts on that?
Yes, I'm actually working on generative AI use cases mostly these days, and Globe and Mail is very strict with their ethical conditions. We do have an AI policy which is adhered. It is to make sure that at two levels. One is that we don't use any PII information. We use anonymous data and should not have any personal information of users if it's used for user analysis. And the second thing is also a lot of, because of generative AI, you can generate articles by AI as well. But Globe and Mail has a policy not to use them directly. And for using AI, any editor will not lose their job. So it is still, the content is written by all the editors. They may have help of certain AI tools like Copilot and Auto.ai. Somebody mentioned Auto.ai is used for transcriptions at Globe and Mail, but it has a very strict policy to not use any AI generated content and push it to directly to production. Everything is human monitored and written.
Awesome. We have actually many questions, which is awesome. I want to jump to Tev, who said, how did you get buy-in from leadership? What was that like?
I see one question for buy versus build approach. Is that what you're referring at? Yeah, I do that a lot. And Peter, if I can say, a lot of times these days, buy is winning because it's less costly to buy instead of investing to build. But it also depends, like you have to focus on your business use case. And if it's cheaper and it is meeting all your needs to buy, then go ahead with it. But do consider the long term. Some of the use cases that we are building, even though there are softwares available that we can buy, is because that we want not our business needs are not met, and we want to build it from scratch and keep adding more use cases in future. So keep the business use case in mind before you decide, and the cost, of course, matters.
Awesome. Thank you for that question, Peter. Any of the questions look good to you, Richa? Paul's, Tef's, Miha's? What is the tech stack that was used for building AI solutions at the Globe and Mail? From Tef, how'd you get buy-in? Paul says, with so many solutions, how'd you select the one that was best for you?
Yeah, I can talk about the buy-in. I think when this paywall product was developed, I talked about the need of it, and everybody was on board because we wanted a good solution for subscription. But for use cases these days, to get buy-in, I have multiple stakeholders. That is the legal team, security team, finance team also takes care of, looks at individual use case. And I talked about how the POC should be killed if it's costing you more than you benefit. So when you have all this data and you have done your research, that's when you get buy-in by showing like, okay, the cost is lesser than the benefit we're going to get. And at the end of the day, business cares about the value it is bringing in.
Totally. One last question. When you buy, who monitors the model? This is from Dimitri. It has to work on your data, not on industry data. Any thoughts on that?
Monitors the model by Dimitri, by that you mean the performance? I'm assuming that this is monitoring the performance, or maybe it can be cost as well. So cost is mostly at our end, and accuracy and other metrics. Yeah, I think if you're talking about the paywall product, we first measure it in our lower environment, and when we are confident, that's when we do A/B test in production. And at that time, the clients are also involved and they are aware of the changes that are done. And through A/B tests, basically, we measure how accurate and how better it is.
Awesome.
Yeah, okay.
Thank you, Richa.
Thanks.
Okay. Thank you. It's absolutely fascinating to hear about the history of this product and how something that was very familiar to me, like reading, consuming articles, to see the bigger picture of all of that. It's a very exciting history. And to hear about it, in your talk, is like, to me, it just gives me so much more respect about like what had to happen behind the scenes, to turn that into something that was monetizable, something that, would be fair to say, like saved publishing, saved, like made money, that was really important. So with that in mind, thank you, Richa. I want to introduce our next speaker, Chad Koziel. So Chad dives into AI products launches in banking, risk management, in the wake of launching the many experiments that are required for AI products and how to stay laser focused on a single user persona. So I think what's really exciting about this is the difference in approach here. Here we're staying laser focused with Chad, on a single user persona. But I think that we're also going to hear a lot of really interesting similarities in terms of the experiments that Chad and Richa have been telling us about. So Chad, with that in mind, Chad, as Senior Manager of Advanced Analytics at TD Bank, you have the floor. Chad.
Thank you kindly. Allow me to share my screen and let's get started. Do let me know when you can see it.
We can see it.
Okay, perfect. So thank you all for joining. Thank you for the introduction. I'm an AI product owner at TD and I launch AI products. So let's get into it. Here we go. Okay, so some of my biases. So first, my industry experience in AI about 5, 6, 7 years, something like that, has been in healthcare and finance. That comes with it like a certain, let's call it slowness to the delivery cycles related to the risk processes and approach in those industries. That informs how I deliver. Next, I have a strong preference for solving novel over improving existing. Again, a bias I take into product delivery. I'm pragmatic over visionary. So even when I'm solving these novel problems, the question is, how do you get a solution into market, a valuable solution into market as quickly as possible, eventually working towards the vision, but starting with pragmatic. And next, the topic of building and buying is interesting and incredibly important today, especially with Gen AI. My experience is mostly in building. Again, working at companies that have the economies of scale to build in-house, it makes a ton of sense almost all of the time. And so with that, let's get into a brief history of AI in banking. So this history starts with expert systems. These are just if-then statements that are pre-created by somebody who knows what they're doing, right? These would be credit decisions. If you have a certain amount of cash on hand and a certain income, you are approved for a loan of a certain size. If you go to 3 gas stations in 30 minutes and use your credit card is deactivated on a fraud case. These are both very intuitive uses of expert systems. And from a user perspective, this is AI. And in fact, it was sort of envisioned that initially we would be able to create AI systems that entirely relied on these if-then statements. From there, we built statistical models. So this came into banking primarily in 1980s, acquisition, retention, segmentation with the rise of SaaS software, and remains the starting point for most tabular-based AI products in the world. In the 2010s or so, with the rise of the random forest algorithm and later XGBoost, we saw advancements to all of those prior model classes. Next best action, in particular, became very important and got added to that. But also, this is still where most AI products can stop. Again, we're talking about tabular problem classes. This is the bread and butter of businesses, and we can solve these with XGBoost and get them to market quickly and cheaply. In 2016, we saw the rise of deep learning. And so this was applied to NLP, speech, check images, that kind of thing. And these were fundamentally new problem classes from everything that had come before. Beginning in the 2020s now, transformers came into play. Now, this is a deep learning architecture. So these are all nested. These are subsets of one another. And these enabled some very interesting language tasks, substantial improvements on recommender systems. This is a foundational new capability. And today now, large language models and the hype that comes with them. So GitHub Copilot, MS 365, Copilot, ChatGPT, all of these are large language models, which are themselves classes of transformers, which are themselves classes of deep learning, and so on. But this is where the hype is, and it's justified, probably. Incidentally, this is where all of my work has been over the last year or so, and TD has some exciting things launching there. So back to something I've been working on maybe for 3 years or so. Here's a ridiculously oversimplified look into liquidity planning. So essentially, the idea is let's have a certain amount of cash on hand. And if we have more than that, then we have excess cash. There's an opportunity cost. We probably could have done something else with that or not had it in the first place. But if we have less, then potentially we would need to fund that via bond sales or something like that. And under duress, you can imagine, for example, if you had insufficient liquidity in 2008 as a bank, you were in a lot of trouble. So let's probably not do that. We probably don't want to do that. Now, this overall problem, this is from TD's balance sheet, October 2023, 6.7 billion. So you can probably sort of look at this and say, hey, if we could correctly size our cash reserves according to the amount we wanted to have, we could probably generate a ton of value for TD. So an AI product idea was born. Let's forecast cash balances 18 months forward, make better liquidity decisions, AI magic, and many dollars grow out of the ground, right? And so in a simplified way, that's true. Not so simple to actually deliver. Now I'll take you into the meat of delivering this product. So starting left to right, this is a pretty typical data cycle or model development cycle. We start with ideation, And in this particular case, even though we can look at that $6.7 billion number and say, hey, there's opportunity here, how do we calculate it? How do we actually know that we are driving business value? And this was new. We had never had a concept of driving value through treasury operations before. On the data side, there's an arcane ground truth. It's fine to say, hey, like, let's forecast cash balances, but are these pending? Are these cleared? Which accounts count? Are all accounts liquid cash? This is a difficult data operation. Next, we have a limited historical record. So back to some of the comments around customer data, personal information. We're not allowed to hold customer data beyond 7 years. Now that's a problem if you want to generate a model that's robust across macroeconomic cycles that span 8 to 12 years. Next, TD has an extremely robust validation operation that occurs via a third party. And if we tackle this at the end, we create enormous risk of rejection and thus all of that sunk cost being washed away and starting from scratch. And so that's a challenging risk to tolerate as a product owner. Then the last one in this particular case, we had no local ML practitioners. Treasury did not have this talent on the bench. And so the sustainment of a model, which was probable to be in market for a matter of years, was going to be extremely challenging. Now, and then last, taking an overall project versus product look at this, you can see that each of these boxes are timed in the months to years. This means a long time to market, some massive challenges in doing so. And if we take this highly chunked section by section approach, which is typical of a project, we are going to subject ourselves to enormous ROI risk. So the first sort of solution to some of these problems was to force reactions on short cadences. So let's take this big chunky piece and compress some of these onto an iterative cycle. So this is a sprint cycle, which I'm sure many people are familiar with. But our goal was less about showing the cool things that we were doing and more about forcing reactions, forcing people to tell us what was wrong with the model, and ideally making go, no-go decisions on the next sprint at the end of the current sprint. Now, this had the corollary benefit of building trust. Again, so Treasury isn't exactly an early adopter of ML, but by virtue of them being engaged and telling us what was wrong and seeing those things fixed every time, they trusted the development process and the resulting model. But last, these validation and sustainment pieces were unbreakable, so we had to have other solutions for those. Okay, next up on the data, or sorry, on the ROI side. So it's sprint 1. This is the very first sprint, 3 weeks in. We showed them a big improvement over baseline using a forecasting model. It was a dumb model, but it beat the existing baselines. And the business said, great, that'll be $50,000 annually saved. And so we said, okay, let's pack up, let's go home. $50,000 doesn't even cover my run costs on a sprint. So let's stop, right? But the business said, wait, no, this is important. We think we can do something. So iteration. And by sprint 8, not only had we improved the model substantially, and not only had the business come back and said, hey, yeah, that we can do something serious on that 6.7 billion. The dollars in this case would be in the millions to tens of millions of dollars saved to TD. But also in key, here's a sensitivity framework that you can use. Now, that sensitivity framework came into play immediately. So it's tempting to think of data as this sort of monolith. Let's just bring the data in. But no, let's sensibly bring data in on an ROI decision-making basis. So we chunk the businesses according to the value sensitivity from that ROI methodology. And we identify which ones have feasible data that we can actually work with. This led us to abandoning some juicy targets, but also when we did abandon a bunch of other products at the bottom end, the business that we were working with said, yeah, of course, there's no value there. We're on board. Let's go. Okay, this is cool. Now, just because we have the data solved, now we're into these challenges of modeling. So data challenges drove the modeling attributes that we were able to select from. So I mentioned the 7-year retention policy, but also we didn't have macroeconomic available to us. And in particular, we had a moving tech environment. We were migrating to MS Azure at the time. And so we didn't have this ability to ingest this macroeconomic data to the modeling environment. This led to some attributes. Let's use a univariate model. In other words, the only thing it uses to predict the future cash balances is the past, nothing else. And further, we added a use limit to this model. It was only available to the treasury team to use during stable macroeconomic periods. Now, that validation piece that creates enormous risk, like we tackled that instead by saying, okay, let's choose from a simple model, and most importantly, a simple model with few assumptions. This is where ML came to the rescue. Statistical time series models are gnarly beasts with enormous assumptions that are very difficult to validate. And nevertheless, we were able to find some ML model classes that made this happen. On the sustainment side, again, this is the first time Treasury was going to use an ML model. So there was a risk of rejection from the business even after we got to the very end. So we had to build trust throughout and in the finished product. But then on the sustainment side, they didn't have the scientific resources necessary to manage a complex model stack. So we had to design something that would perform without significant intervention on an ongoing basis. This led to a third set of attributes. We underfit the model. So in other words, we didn't maximize performance from the stack. We left some on the table in the understanding that would help generalization over long periods of time. We ensured transparency in the model, that it was a model class that could be understood, and we built interpretation tooling so that the users could figure out what was going on under the hood. And last, we proved out automated retraining. In other words, the model would refit on an ongoing basis so that it always took advantage of the newest data. And a quick seg, like now that we're talking about the model building process, this is sort of, maybe this is familiar to some, maybe not to others, but it's that many experiments build an AI product. So we start with an idea, concept of something we want to implement in the model. And through a cost of time and treasure in particular, and the cloud costs, which are significant, we get one of a few outcomes. Maybe it's a great positive outcome, a shining star that we can incorporate into our product. And this now transitions into a very standard sort of software delivery methodology, but notably, each incorporated experiment is probably adding to TPO, to the total cost of ownership, TCO, on this. More commonly, probably most of the time, we reject the experiment. We document it because inevitably somebody's going to ask us, why didn't you do this thing? And you are probably performing hundreds of experiments in the course of delivering one of these products. On the other hand, we frequently get this outcome where we're not entirely sure. Maybe we just didn't conduct the experiment right. Maybe we need to change some of the approaches we took. We think about that, and we'll try again and iterate. And the important outcome, the important takeaway here is that any given experiment has an uncertain payoff and is unlikely to be incorporated into the product. And this just creates a strong contrast with the software development mindset that adds an inherent uncertainty to AI product delivery. So back into this actual product that we're doing, transitioning from a project view to a product view. So we launched this product in November 2021, which is about the time that interest rates began rising. But it was a univariate model. It was simple with limited businesses, and it worked. And it added an enormous amount of money in value to TD. We got back at it once we had macroeconomic data available to us. We built a cutting edge multivariate model using a model class that wasn't even available. It wasn't even launched until 2022. And we removed this assumption of a stable macroeconomic environment as a result. So this is something to use all the time. Now, this is launching as we speak. In the future, in release 3 and beyond, we're going to add businesses to build this out as a platform, generalize this solution. The intuition here is that forecasting cash balances on a monthly basis isn't that much different from forecasting how many workers you need in a contact center over that same period, or how many customers are going to attrite, or what your cloud costs are going to be. And you have armies of people doing these tasks via human intuition. And we could, if we sufficiently create a usable solution that doesn't have a strong barrier to entry, we could put this into many people's hands. So wrapping up, the AI product lessons, or just let's call it product lessons in general, business chunking, incrementing complexity as we build a product, unlocking new data streams, new attributes. These are all like highly applicable generally to AI, but quite specifically to Gen AI, which is again the field I'm playing in predominantly now. Next, that tough ego busting choices are going to be necessary. And so what I mean by this is we're frequently going to leave performance on the table for all sorts of different reasons. We're going to have to cut the model development process short before we've gotten to the model that the science team really wants to get to, and we're going to have to kill a lot of products. I think I have a failure rate of about 80% top of funnel, which is where I want my high failure rate. But last point, be extremely cautious about translating between contexts. So we're talking about like model choice, time to market, effort. And just in particular, there are probably as many AI product owner contexts as there are AI product owners. And so if you're interested in the space, talk to as many as you can. Try to understand the breadth and diversity within it, because it is tremendous and everybody is working to optimize against different objectives. And so with that, I'll open it up for questions.
Awesome. Thank you so much, Chad. All right. We already have 2 questions on the table. One of them from Tiba, who are the ones that you needed their trust and to validate numbers with. Do you want to start with that, and then we can move on to Dimitri's?
Yeah, it's a good question. So in this case, we've got a small team of Treasury experts. These are people who live and breathe the Treasury decision-making process that, frankly, like needed to understand where all these numbers are coming from. Why are the numbers we're presenting them with in terms of ground truth cash balances 1%, 10% different from what they've seen in their other data feeds? These are career professionals who highly skilled at Treasury decision making, and it was this very small, mighty team that we were working with throughout the process.
Awesome, thank you. And we also have a question from Dimitri. Okay, how did you overcome the explainability problem and build interpretation tooling?
Yeah, I mean, like this was in the explainability problem is from model class selection predominantly. There's things you could do on explainability even with deep learning models, but you're not going to get it. Ultimately, not as easily, not as well. The statistical time series models, that was like an alternative model choice class. So I don't know, maybe a RIMA or Holt-Winters or other things. Those are highly explainable models. That even our Treasury people had generally some degree of statistical background and understood, but they didn't offer the performance, and crucially they had these like wild statistical assumptions. So we decided on certain model classes in advance that met those criteria of explainability, and in particular in this case the digestibility of trend and seasonality, and making sure that was introspectable by these business users. And then just like, quite frankly, we built a bunch of dashboards and automated visualization tools that allowed them to introspect what each of these models was doing at any given point in time, at any point of that model's life cycle, present or past. And so they were able to sort of click through using, you could think of it as a sort of a Shiny or Tableau type interface that gave them the confidence that they understood what the model was doing and what its limitations were.
Awesome, thank you, Chad. You may be looking at the questions in the chat.
Yeah.
We have 2 questions. Yeah.
Okay, I mean, like I love killing things. So I love killing things. I mean, like products. I don't. I'm mostly vegetarian. But like, man, I love killing things. And so the main reason we kill things is, well, all of those reasons. So we have valuation is a big one. Like I can just say that my team's run costs are ridiculous. They're extremely high. And ensuring that we have a problem with a sizable value is key and extremely difficult, especially when I'm playing in this space of novel problems, right? Like where I have existing problems, like fine, I have probably a framework I can work with. In novel problems, it tends to be probably the number one reason. The valuation doesn't appear. The other primary reason, like we kill things because we don't have the data to support it all the time. Like TD is a data-driven organization, yes, but also, we have such a complex organizational structure and data architectures that data is a big reason, but it's not that interesting. We can usually figure that out pretty quick. The other big reason we kill things is because we perceive that even if the product is built and meets all the specs, it's unlikely to be used. So I like opening my kimono just a little bit, right? Like TD, probably like many large organizations, has a lot of very expensive models, exquisite models built that never got used. And again, like referencing the horrific run costs, like I can't tolerate that. And so I have to design my product approach to figure out, is this model going to be used? And really like testing out users, forcing reactions from users really early in the process and arriving at kill decisions primarily on that basis.
Awesome. And just to recap for the recording, the question from Tiva was if you'd summarize the main reasons to kill many ideas early in the funnel, which Chad was just answering. All right. We also have 2 questions. I want to make sure, be cognizant of time. We actually have 1 more minute. Between these 2 questions, I would say pick one. How do you manage the risk of macroeconomic changes?
So,
yeah, go ahead.
Yeah, I'll take. So the question is basically, how do you incorporate traditional and ML? And are you using or incorporating Gen AI? The short answer is that the future model classes that are going to solve this problem will use transformer architectures. And in fact, this latest model, the first architecture that was tried was something called temporal fusion transformers, which it offers a huge value, when you are forecasting from very large data sets, which TD has access to. And the future of this product is something probably called foundation models, using transformer architectures. Those are topics you can look up after if you'd like. I'd be happy to send some links on it, but that's the future. Probably not Gen AI specifically, but the interesting angle is that you can use those Gen AI architectures on tabular data, specifically very large tabular data, and soundly beat the ML classes that came before, including extremely well-tuned XGBoost models. And so that's the future that we see for products, for this product and for others besides. In terms of statistical versus ML, really, like, we were open right at the start as to what we chose and why, and it just so happened that in this case, an ML model made sense. But you can imagine if we had a team that was capable of sustaining statistical models, statistical time series models in particular, then we might have been able to eke out a little bit more performance from one of those and may have implemented it in this case. Just circumstances didn't play out that way.
Awesome. Thank you, Chad. Anna-Roza had a question. How do you manage the risk of macroeconomic changes still to come, given our current economic state, if at all?
Yeah, I think that's a fascinating question. So maybe the first one is that we don't, but instead we ensure that the people using the model know what the model doesn't know. So, in this particular case, we tell them which macroeconomic indicators are going into this model. And then what they end up doing is what their plan for cash balances isn't the model output. They layer on human intuition on top of it, understanding what the model doesn't know. And when we talk about informational support tools, this is key. Can you extremely rigorously decide and state the informational components of the model versus the ones your users can bring and challenge? And if you can do that, interestingly, your outcome from this isn't from the model itself, it's better. It beats both the human intuition-based forecasts of and the model. And so that's in fact how we're accruing the value of this, not on the basis of what the model's outputting, but on the basis of the better decisions that are now being made. And so anyway, that's how we try to manage this challenge.
Absolutely amazing. I want to say thank you, Chad. the word that I left your presentation with, and I felt this way too, actually, with Richa's, is the word incredible. It's two incredible stories, very, very different stories. Chad's yours in finance, Richa's in publishing. But both of them, I leave with the word incredible. It's like you managed to cram so much in different ways, based on these two products. So I want to say thank you so much, Richa. Thank you, Chad. And also, Pallavi very helpfully put into the chat. Please take a few minutes to fill out this quick survey. There's a link to it. Please, 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 we would love it so much if you could fill out that quick survey. Yeah, and it's a great chance for us to be able to connect. We have a link from Chad from a NVIDIA blog, as well as an article that was requested. And we have thanks, and thank yous from Dimitri, Tiba, and Pallavi very helpfully showed the survey link again. And I want to say thank you so much. I can't wait to see you at the next event. Some of the questions that were asked, we are actually going to make the topics of the next events. So thank you again, Richa. Thank you, Chad. And thank you so much from the team at the AI Product Management group at TPMA, at the Toronto Product Manager Association, Product Management Association. And please, please, please do stay in touch. It's been a blast. Thank you so much. Yeah. Pratik says, please register as a member on the TPMA site. It is free currently to join. Once you're logged in, you'll find the option to join the Slack. So yeah, it'd be great to hear from you in the Slack. Thank you so much. Okay. We have the link for the survey, and thank you so much. Talk to you soon.
Thank you.
Thank you, Richa. Thank you, Chad. Take it easy, everyone.
Thank you, everyone. Thanks, Ray.
Thank you.
Thank you, Ray.
Thank you.
Thank you, Ray. Thank you, everyone. Have a good one.
Good night. Good night. Take it easy. Okay, let's wrap up here. Good night. Good night.